Imagine it, standing on a strikingly more primitive version of our world, looking up at the night sky as a bright red light bursts to life. What goes through our ancestors' minds? Do they think it's the work of primordial gods? Is it a sign of ruin? The crimson light show is brief, but even with its passing into the depths of space, its effects may be felt even today. I'm Eric Malachite, author of Echoes of Olympus, Mons, and welcome to a new series of videos based on articles I've written for my website, ericmalachite.com. Today's video is all about a study which suggests that a red dwarf may have passed extremely close to our parent star. Let's go ahead and get into it. The last decade or so has been filled with unfounded conspiracy theories of rogue planets and stars smashing through our cosmic backyard like celestial wrecking balls. But what if such a star did, at one point, come close to our parent star? Well, that's exactly what scientists at the University of Madrid and the University of Cambridge think may have happened 70,000 years ago. A 2015 study suggests that a nearby red dwarf may have come as close as the Oort cloud and disturbed many asteroids and comets in the process, among many other objects as well, making our solar neighborhood a bit more chaotic to say the least. For those of you who don't know what the Oort cloud is, it's almost like a shell of icy objects that exist around the sun at the outermost reaches of our solar system. And it's named after the astronomer John Oort, who first theorized of its existence. Last year, two astronomers from the Complutense University of Madrid, two brothers, Carlos and Raul, along with another researcher from the University of Cambridge in the UK, have analyzed close to 340 objects in our solar backyard, and what they found is striking. Using numerical simulations, we have calculated the radiance or positions in the sky from which all these hyperbolic objects seem to come, explains Carlos. In principle, Marcos continues, one would expect those positions to be evenly distributed in the sky, particularly if these objects come from the Oort cloud. However, what we find is very different, a statistically significant accumulation of radiance. The pronounced overdensity appears projected in the direction of the constellation of Gemini, which fits the close encounter with Shoal's star. Shoal's star, the red dwarf in question, is now 20 light years away from our sun, but 70,000 years ago, some scientists believed that its orbit would put it very close to our system, coming within at least 1 light year of the sun. That may not seem like much, but it may explain why some objects in our solar system appear to have a V shape in their orbits, rather than the typical elliptical orbital paths we tend to see. Red dwarf stars are typically pretty dim, so any hominids gazing up at the night sky would only see it if it flared, which red dwarfs have a tendency to do often. They're extremely active. If you like this kind of content, go ahead and hit the subscribe button and ring that bell to see future updates. I've been Eric Malachite. I'm the author of Echoes of Olympus, Mons, and you can find the book on Amazon in print and digital formats. Link is in the description.